So we're gonna start to explain this chapter. 2.1 represent relation and function, page 72. It's chapter 2. I have this section. First, you need to define what is a relation. A relation is a set of ordered, okay? Any set of ordered is a relation. For example, here I have, if you can see, 2, 3, and x is 2y3, x minus 1y5, x4, y minus 2, x9, y9. This is a relation, okay? The domain is the set of all x values in the relation. So what is the domain? If I ask you here, in this relation, what is the domain? And just the values of x. So what is the domain here? The domain is 2, minus 1, 4, 9, 0. Now I can ask you, so that's it. This is the domain. You need to put it in order. So in order, minus 1, 0, 2, 4, and 9. And you need to put this, I know it in French, accolade. Okay, I don't know if it's brackets in English. La. I don't know what we call it in English. Okay. These are the x values written in a set for smallest to largest. Okay, so we're gonna write from smallest to large. Now, what do we call range? The range is the set of all y values in the relation. Okay, so what will be representing the range? And the output. So my input is x, my output is y. Also, we're gonna put it in order. So we're gonna put the range in order. I have minus 6, minus 2, 3, 5, 9. So as a conclusion, a relation is a set of points that represent x and y. X, we call all the values of x the domain and the input, and y are called the range, the output. But the technical words are domain and range, not input and output. Now, what does it mean function? A function f from set A to set B is a rule of correspondence that assigns to each element x in the set A, listen to me, exactly one element y in the set B, exactly one. It means x can have one y, and I cannot have for the same x two y. Let's give you an example. I have, this is the domain, so we said x represent the domain. This is my range. If I look here, for each x we have, if you look, exactly one y. Yani, in another word, from x, it's going out just one arrow. I cannot have from x going two arrows. Halla, 2x can have the same y. For example, 3 can have 6 and 5 can have 6. I don't care. But from x, I cannot have two arrows. Yani, for each x, we have exactly one y. And this x1 has 4, 2, 2, 3, 10, 4, 8, 5, 6. So for each x, we have exactly one y. If we don't have exactly one y, we don't call it function. It's called just a relation. Okay, function, yani for each x, exactly we have one y. All x are assigned. Sure, all the x's should have a value, and if x doesn't have a value, it's not a function. And must use all the x's. You see the first one, so we need to use all the x. And no x has more than one y. So all x's should be used, yani for any x, we should have a y, and exactly one y. This x should have exactly one y. Okay, so just one y is assigned to just to x. Okay. Now let's look at another relation and decide if it's a function or not. Okay. So if I look at this one, I just want you to see. Do you think this is a function? Okay. Miss Mirella said we need to use all x's, and all x's should have values. Okay. If I look here, all the x's, they have some value. So must use all the x's. It's verified. Then Miss Mirella said for each x, you need to have exactly one y. 1 have 4, 2 has 4, 3, 4, 4, 4, 5, 4. Okay. But from one x, it's going one arrow. So yes, it's a function. So for each x, we have exactly one y. So yes, it's a function. So what do we call this relation? Yes, it's a function. Let's go to another example to see. See here the remark. The second condition says each x can have only one y, but it can be the same y as another x gets assigned to. So I can have all the x's with one y, no problem, okay? Now let's see this one. Let's check if it's a function, yes or no. What do you think, guys? Is it a function? No, because 3, C doesn't have any image, doesn't have any y. So no, we didn't use all the x's, it means it's not a function, okay? Now how are we gonna check if it's a function by graphing? Okay, it's very simple. We need to do the vertical line test. If the vertical line cuts the function in exactly one point, it means it's a function. Why? Now notice if I said it cuts in one point, it means this point x had exactly one y. But here, if I look at this point x here, this one, okay, this x here, they have two y's, so that's why it's not a function. So all the time here, when I do the vertical line test, the line should cut the function in exactly one point, so it's a function. If it cuts the figure in more than one point, it's not a function at all. Now if I look at this point here, I will repeat again. هيدا البوint, for example, let's say it's -4. It has two y. It has this one here, and it has also this one here. Okay, so that's why it's not a function. So a relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. So it should cut just the figure in exactly one point. This is a test graphically, and if I give you a graph and ask you, does this one represent the function? You just try to do vertical line test, and it should cut the function and the figure in one point. For the graphing, this one we're gonna do it later together. So that's it.